I'm Laura Grassie. I'm a STEM coordinator for UHI and I'm based at UHI Perth, and today I'm going to talk to you a bit about coding. So what is coding? Well, it can seem really complicated and it's really easy to think it's going to be difficult to do. But all coding is the way that we give instructions to computers to allow them to do what we want them to do. Now, computers understand different languages, just like people understand different languages across the world, like French and Spanish. Computers can talk in different ways, and we can use these different languages to communicate our needs and get computers to do what we need. Coding underpins many of the different things that we have around us, not just from computers, which obviously we know, and the software that they use, but games, and also other things including microwaves, dishwashers, and even cars. One of the key concepts of coding is understanding that it's about breaking tasks down into individual components. We call this writing an algorithm. It is just the instructions broken down step by step. And it's not just for code. Algorithms can be found everywhere. For example, a recipe is an algorithm to make a cake or a specific dish. It could be directions to a specific location, or it could even be instructions on how to make a little Lego thing. So for example, if you have all of the Lego pieces broken up like this, how can we get that Lego into the figure that we see? We'd have to break it down step by step, the instructions that you would need to do. For example, place the yellow piece on top of the white piece, followed by the smiley face. You would then need to add the two pieces that have the eyes on and the white piece, the white 4 piece at the back. Then you would need to add another yellow 8 brick on top. You would need to add 2 clear pieces on each side. And then finally a clear 4 piece with the red piece on top, and finally a bit of the straw. So you can break down the instructions of how to make this Lego figure into individual steps. You need to include all the necessary steps to get the finished product, in this case to make the Lego piece. If we had missed out some steps, we might end up with a Lego piece that doesn't look quite right because it's missing things. Or for example, if we've done the steps in the wrong order of when to put things on, it might look very different. For example, looks very different. That is an example of a screen-free coding activity that you can do with your class. Get them to decompose or write down step-by-step an algorithm for how to make a particular Lego piece. But there are other screen-free coding activities that you can do. These are really useful because you don't need any technology. So if you don't have laptops or iPads or any other technology available, you can use these screen-free activities. It focuses on logical thinking and problem solving, and it teaches them the core basics of how to write a program and how to do coding, which is that breaking a problem down into individual steps, putting those steps in order to create a functioning program. There are lots of different screen-free activities available. For example, Twinkle has lots of screen-free coding resources, and other places as well have them. It could be as simple as how to make a Lego object. It could be how to code their fellow classmates around a classroom, or it can even be how to break down a dance and code a dance into individual moves. Now, I want to explain some of the other programming things you will come across in a classroom that is really useful. The first one is Scratch. Scratch was created by MIT, and it is what we know as a visual programming languages. It's very similar to Lego, actually. You code with blocks that you click together in order to make a sequence or program. It's a visual programming language. It's great as a first introduction to kids. It's free to access, and you can also have a teacher account. This teacher account is fantastic in that it allows you to see your pupils' progress and make accounts for your individual pupils for them to save their work on. They can create a wide variety of projects, from interactive stories and computer games to animations. As a teacher, you can request a teacher account, which, as I said, will allow you to set up individual pupils' accounts and monitor them. There are a few things that you can note. Scratch can be accessed online via scratch.mit.edu, and you can access the editor straight online. If you want to save your projects, you will have to be signed in to an account to save the projects, or you can also save a copy locally to the computer via the online editor as well. There is also a desktop editor available, which is great if you're in a school or a location where there's maybe not great access to internet. It gives you all the same features and functionality, or most of the same features and functionality as the online Scratch, and again allows you to save them direct to computer, or if you are signed in and connected to the internet, you can also save them to your individual Scratch account. One thing to note is pupils can share their work publicly with the wider Scratch community, and this often also allows comments and people to leave comments on their projects. This is something that you can disable if you do not want people to leave comments on projects, and there is no need for students to actually share their projects as well. I also want to talk about another great piece of kit that you might have hiding in your schools, which is the microbits. These are, in fact, tiny computers, and in this case, this one's attached to a battery pack. I've pre-coded this one with a dice game, so if we shake it, it should display a different number. And it's randomly going to choose a number between 1 and 6, just like you would if you're rolling a dice. Now, these can seem really scary to use, but they're actually quite simple. So they plug directly into the computer with a USB wire, and if you go onto the MakeCode website where you create your code, there is a download button that you can click on. Clicking on the download button allows you to download the code that you've written directly on the microbit. And then when you unplug it from the machine, you can actually take it away and use that code hands-free. Now, the microbit is great. It's got lots of different things and sensors on it. One of the things to note though, there are 2 versions of microbits. Version 1, which I have here, and version 2. Version 1 has programmable buttons like you can see here, A and B. It also has this 25 LED display that is programmable too. It also has a plug for a battery, a compass, an accelerometer so it can tell when it's being moved, and a light sensor and a temperature sensor. The version 2 has a few more additional features, including a built-in microphone, a touch sensor, and a sound sensor as well, and a speaker. It's important to note that there are 2 different versions, because when you go on the microbit website and you look for projects, there are in fact projects available for both version 1 and version 2. Note that the version 2 specific projects will require the version 2 microbit, because it will be using features that are not available on the version 1. There are different languages you can program a microbit in. It has its own block programming, which is very similar to Scratch. So if your pupils have used Scratch or another block programming language in the past, it will be quite familiar to them. However, you can also use it with more complicated language, including JavaScript and Python. So it's great for those students that maybe are trying to move on a little bit from the basic block programming. Microbit.org has loads of different tutorials and projects that your students and you can follow very easily. Another thing to note that is, while you can't make a teacher account for Microbit, there is something called Microbit Classroom. Now, Microbit Classroom is great in that it allows you to set a code that can then be seen by your class, and they type in to access the classroom. This provides an environment as a teacher, you can see every single student in your class and the code that they are currently doing. It means that you can review code without having to walk around the classroom. It also allows students to put their hand up when they have a problem. You can suggest changes to their code that they can implement, all from the comfort of your own desk. There is also Hour of Code, so hourofcode.com. It has lots of different projects available, and a lot of these are themed along the lines of Minecraft and Frozen and other topical themes that children can engage with. All the projects are aimed to be for an hour, and they're easy to access in the classroom. You can also filter the Hour of the Codes by the technology that the children will be using, including screen free, and by any specific tags such as music or mathematics or language arts as well. One of the things that can be challenging when it comes to coding is understanding some of the basic concepts of code. So I'm going to talk through some of the simple basic concepts of coding so you have a start when you get started with your class. The first one is initiation. So in order for code to run, it has to be started. Something has to happen in order for the computer to know it needs to start. For example, in Scratch, these are called the hat blocks. As you can see here, they have that kind of rounded top on them that kind of makes them look like a hat, and nothing will fit on top of them. These are initiation blocks or start blocks. We have when flag is clicked, so the computer will know when the flag is clicked, the program should run. When this sprite is clicked, again, when you click on the sprite, the program will run. And when space is key press, you can choose any key on your keyboard from the drop-down menu, and also things like loudness. This isn't all the initiation or start blocks that are available in Scratch, but there's some of these, and these need to be present in order for code to be run by the computer. The next important concept is understanding that sequence is very important. That is, the order in which things appear is the order that they will be run. Computers tend to run the code one step at a time unless you have programmed specifically concurrent code to happen at the same time. In a set of code like you see here, it will, for example, in the first one, when the flag is clicked, it will play the sound meow until it's done. And then only when that sound is finished will it then move on to the move 10 steps. Once it's moved those 10 steps, then it will turn 15 degrees. In the second set of code, you can see when the flag is clicked, it will start the sound meow, and then while the sound is still playing, immediately go onto the move 10 steps and then turn 15. So this shows you how it will still do it in sequence, but there can be minor or subtle differences in the codes that your students or you choose that could decide, for example, if a music is playing alongside a bit of code or nothing will happen until that music has stopped. As well as understanding that programs are executed sequentially, we can also look at some of the other important aspects of coding. For example, we can talk about repeat loops. Repeat loops allow us to execute code multiple times. So whereas before we were adding in multiple move 10 steps and turn 15 degrees, we can just add 2 inside the loop and decide how many times we want it to happen, in this case 10. We can change this number to easily change how many times we want something to happen. As well as the repeat so many times loop, there are other repeat loops available. For example, we can have a forever loop. If we add the same blocks back in, this will then cause the sprite to move and turn continuously until the program is stopped. This can be useful, for example, if students want to play music throughout their game or story. Another key part of coding is understanding conditionals. Sometimes we only want a certain piece of code to happen if something else has happened. For example, we might only want our sprite to move once we've pressed a key. For example, I can add the move 10 steps and I can say when the right arrow is pressed, the sprite will move. However, we have a problem. I'm pressing the arrow and nothing's happening. This, again, you have to remember, sequential. The computer, when the flag is clicked, is checking once to see if the right arrow is pressed. It's not, and therefore it's not executing this code, and the code is now finished. If I want the computer to continue to look to see if the right arrow is pressed all the time, I need to also add a forever block. Now when I press the flag, anytime I press the right key, my sprite moves. Finally, one of the most challenging or scary bits of coding, especially for teachers, can be what do you do when something goes wrong? How do you help your students if their code isn't working? This can be particularly daunting if you don't feel comfortable coding yourselves, but don't worry, there are some very easy ways that you can teach your students to work through to help them figure out where their code has gone wrong. The first one is to actually write down with a pen and paper or pencil and paper what they expect their code to do step by step. This is actually a good thing to get them to do before they've even written it in the program, because then they can refer back to it. They might find by doing that and matching it up to what their code has been written as, they realize the error that they've made. Another one is they can take code or blocks off one by one, start just adding the blocks back in one by one, and testing to see if what they think would happen actually happens. By adding the codes of blocks on one at a time, you can often identify where you've gone wrong. Finally, this works with certain types of code. Create a table of inputs and expected outputs. So when you do certain things like press arrows or press certain keys, what do you expect to happen? Then test those and see if the outcomes are as you expected. Again, this will often give you an indication of where in your code you've gone wrong. But one thing I want to say, it's okay to not know what you're doing. There's lots of help available online on forums, and also you can learn alongside your students as well. You can often then do these debugging as a class activity and maybe help work as a group to determine what's gone wrong. Finding time to do coding can seem difficult, but it's actually really easy to link coding in with other areas of the curriculum. For example, with numeracy, you could use Scratch to create interactive math quizzes or explore shapes and patterns. Literacy, Scratch again can be used to make interactive books where students create their own stories and write text to go alongside them. And it can also fall into health and well-being, developing teamwork through group coding projects or activities like programming robots for challenges. I hope this has been helpful in explaining some of the ways that you can get started with coding in classroom. You do not have to be an expert or have lots of experience in coding to bring this to your